So thanks for taking the time.
Thank you for inviting me today.
How did we end up here? I mean, like your mission, it dates way back, right?
You're right. So the whole adventure started almost 18 years ago.
8 years.
18.
18 years.
18 years ago. I was having a party,
It's
barbecue.
always something good. Everything starts with a barbecue.
Everything starts with a barbecue. And there was this opportunity for young graduates in ESA. And there were a bunch of positions open. And I was thinking, yeah, it would be cool to work in ESA. I'd been there once as a student, and I loved the environment, the European environment, and everything felt so stimulating. But okay, my grades were not so good. So I was like, yeah, my chances probably, throughout Europe, there are so many good students. So I waited really the last minute. I was sure I was never going to get in. So I think the deadline was midnight. So 11:30 after a few bottles of wine, my wife says, yeah, but, you should try. I said, okay, let's give it a try. So I went on the website and filled in the forms. And there were two positions that I was particularly interested in. One was asteroids, asteroid mission concepts. And the other one was about future technologies in the advanced concepts team. And I was hesitating. And in the end, I selected the asteroid mission. All I knew about asteroid at the time was one picture of an asteroid for some reason I had on my desk. And I applied. I was called for the interview. So I traveled to Nordwijk, and eventually I got the job.
What were you majoring in at university?
Aerospace engineering.
Okay.
And actually, I still had to complete my studies. I had one exam left. So it was a very tricky situation because ESA had proposed my take-up duty 1st of July, and my last exam was only a few weeks before. I was like, if I missed that exam, Anyway, all went fine eventually, and it was the start of a fantastic adventure.
So you jumped right into the professional, the work life.
And I remember I arrived, there was just so much going on. This professor called Milani just proposed a mission concept called Don Quixote to ESA. ESA was interested, and I was there to get it started really with my boss at the time. And it was just so hyperactive. I loved it. There was so much adrenaline and running all the time, and yeah, a lot of work. I learned so much.
Why do you think you won ESA over?
I think the idea was completely innovative. Interacting with an asteroid was something that nobody ever thought about. And it was really a direct way to test planetary defense instead of more conservative approaches and of looking at them from far away with telescopes. As somebody says, the idea was to get there and be personal, get close and personal with an asteroid. The only information we had at the time were just very fast flybys of space probes, flybys of a few seconds or minutes, so very limited information.
So where is that asteroid?
So that asteroid was Gaspra, but the proposed mission, that was part of actually my early work, was to select the target asteroid, the perfect target asteroid. So to help us in that, we hired a group of scientists. At the time, in 2002, there were not so many working in asteroid science, and trying to work out which would be the parameters describing the orbit of an asteroid that would be ideal for planetary defense. So you have to think about the motion of the asteroid. If you push it, how would it affect its orbit around the sun, and the possible interaction with the Earth.
Are we talking about the asteroid belt?
No, we were talking about asteroids that are close to the Earth, so things we call near-Earth asteroids. But there are hundreds, millions of those asteroids, and all of them have very different orbits. But you can somehow group them by orbit type. Those that intersect the orbit of the Earth, those that stay always outside, always inside, and that the intersection point drifts in certain ways over time. So all those parameters are the ones that we were looking at, and the size, of course, of the asteroid. And among those, we selected 2 asteroids, nominal and backup. In space, we always have backups. And work with these 2 asteroids that have no specific name, just numbers, for many years. And it was really exciting. It was really exciting. We had all these ideas about designing satellites, reusing designs from Earth observation satellites or telecom satellites or new satellites. So we're really exploring all kinds of different designs to achieve this mission.
So the overall goal is to find out if it's technically possible to deflect an asteroid in the case that a dinosaur era asteroid was on collision course, right?
Correct. So the idea was to test deflection technique called kinetic impactor. The physics tells you that if you hit an asteroid at high velocity, you will change its velocity and therefore its trajectory, and you can knock it off course if you were on a collision course with Earth. The fact that we don't know the interior structure of asteroids, many of its properties, is the problem, because we know the theory, but we don't know if it really works as we expect. And that's the purpose of an experiment. And the funny thing is that on Earth you cannot model it, you cannot test it in laboratories because there's always gravity. And asteroids, actually the threatening ones for the Earth, are several hundred meters in diameter. So even if you reproduce impact experiments, which we do, you always have to scale down, and you never know how the physics really scales. So at some point, when you think you have, let's say, the models as good as you can, you really need to test for real. So that's the whole purpose, was to say, okay, today we think we have the technology mature enough to deflect an asteroid. Will it really work? And that's what the mission was about. So we wanted to send a probe to impact an asteroid at high velocity, and a second probe to study the effects of the impact and gather, let's say, the before and after information about the asteroid, the shape, the mass, the crater size, the interior structure, all those parameters that then you would plug in a computer model to figure out if you can reproduce on a numerical world what has happened in space.
Let's cut corners right now, because it's getting really exciting now. From what you've seen so far, is my question would be, are we able to do it in case the dinosaur thing were approaching?
Yes, we are.
Good, thank you, goodbye.
Yes, we are. And DART just proved that a year and a half ago, impacting an asteroid called Dimorphos. It was an incredible mission, which started on the Don Quixote concept I mentioned in 2003. So it was a long journey to get there, but eventually we did this experiment, and it worked almost completely different from what we were expecting, which is, again, the purpose of doing experiments for real. And it proved that we really needed to do this experiment. So there are 2 main results, I would say. First of all, we proved that we have today the technology to send a probe that can automatically target and hit an asteroid at very high velocity. We're talking about more than 28,000 kilometers an hour. And of course, you cannot fly such a spacecraft from ground. So it needs to be, the final target, it needs to be autonomous. And it's not so easy.
Huh.
And it worked well. It worked amazingly well. And the second main result is that the deflection was much higher than what we expected.
And no one knows why.
And nobody knows why. So that's why we sent the second probe as we had planned to figure out why.
Wonderful, wonderful. Now, cliffhanger. Let's not dive too much into what is about to be happening this year. Let's go back to when the mission started 18 years ago. So you got the job. You were all by yourself, I guess. No team available yet. How did everything start?
No, actually, I was lucky. In ESA, we always work as a team, and I was the newcomer, so I had lots of help, and we really worked as a team. It was
the newcomer boss.
No, I was not the boss. I was actually the last one in the ladder. No, I had a very visionary boss at the time, Andres Galvez. He taught me a lot, and he was amazingly creative in coming up with mission concepts. I think he was a physicist. He's a physicist by training. I think physicists have this peculiar mind of sectioning problems and finding interesting solutions. And many other colleagues in ESA, system engineers, propulsion engineers, electrical engineers, all of those, we were working in a lab that was today's ancient history in wooden barracks, and coming up with several mission concepts and several spacecraft design. And on top of that, we had a team of scientists supporting us, telling us all they knew about asteroids to help us design this mission. And these scientists were amazing. They were so passionate about asteroid science. They would spend hours and hours and hours, even off work, telling us all they knew about it. And I feel it was the first time actually I found a group so motivated and willing to give all their time for us. I really felt privileged, and I learned a huge amount of information on asteroids at the time. And as a matter of fact, I'm friend now with all of them. And the community, the asteroid community, since then just kept getting bigger and bigger and bigger. And today is a big community, and they keep doing science and research and understanding more. There have been more missions to asteroids, and it's just a fantastic community to work with.
What's your secret behind that, to really get people engaged? One of your colleagues, Margarita Cardi, sent me a video the other day from a Sunday where she was going to a bakery to get breakfast for her team, and she was like, "It's Sunday, but still I'm working and I love my job." So how Margarita is building the CubeSat for your project. So what's the secret behind that kind of engagement?
That's a very good question. Well, first of all, I should say that I would say that planetary defense
is a good topic.
If I were to tell you that we're gonna work together to come up with a space mission to save planet Earth,
that's pretty cool.
Who would not want to work on it?
Do you have is that actually also on your business card?
No, it's just AR project manager.
No, because that would be pretty cool to leave your business card on a random table, just lying there in a bar.
Yeah, I know. That's I have actually there are two persons on the planet that I know who have this kind of business card. It's planetary defense officer.
Black shades, black sunglasses.
But no, mine is not as cool. But the topic is fantastic, and for an engineer, for an aerospace engineer, is like a dream come true. So it's easy. I would say it's very easy. And I think the other. I don't have a strict secrets, but I would say I have a vision. I always had this vision that we could achieve a mission like this in maybe a different way than typical space missions that take 20 years, mostly because we could cut corners and we could accept higher level of technological risk and maybe less performant payloads, because after all, the measurements we need to do are not so difficult. And third, I always told everybody how little I knew about everything.
Nice.
And which is true. When I started, I knew nothing about asteroids. I just read a few pages, before the interview that I could find on a book. I hardly knew anything about mission design. I've done a few courses at the university. And when I, 20 years later, when I started the HERA project, I never managed a space mission myself. So all of the time, I've always told my teams or the people I work with how little I knew, but I had this vision and I wanted their help. So my focus has been in engaging people and directing them in the same direction,
bringing their strengths.
Exactly.
And not tell
I
them.
think everybody feels like it's a necessary piece of the puzzle to get the project done and getting everybody together.
So what was that strong vision that you were talking about?
So the vision was to, which I inherited from my boss, from Andres and Frank Unger and many others, is really to that it's worthwhile testing in space a planetary defense mission before we actually have an asteroid heading towards Earth.
Makes sense.
Which would make sense to most people. But as you can imagine, you go to a politician and you say, can you give me 300 million euros for a space mission? And they ask you what it is about. And then they say, yeah, but when is this asteroid coming? And you say, it's not coming. Maybe it's in 1 century. Maybe it's in 1,000 years. We don't know. And this type of political decision is always outside the political landscape of any decision maker. So it's very difficult to engage in such a discussion. Also, asteroids sometimes have this giggle factor where, there are so many media talking about threatening asteroids passing by the Earth, and nothing really happens that make the topic a little bit fun and not serious. As a matter of fact, when we started, most of our colleagues were laughing when we were proposing this mission. It was not scientific enough. It was not technological enough. It was not interesting enough and worthwhile investing such amount of funding.
Sometimes such a reaction is encouraging also, because then you're onto something.
That's actually true. And the project had so many setbacks that really pushed us to keep going, because it's easy to say it's not cool enough when you have your pockets full of funding for other missions. But starting something from scratch, something that still doesn't have a house, even in a space agency. When we started, there was no planetary defense program. So there was no house for it. There was no place. There was no program. And nobody really understood the meaning. Asteroids were these strange objects that nobody really cared about.
That sometimes destroy entire biospheres.
Yeah, but it's something, in 65 million years ago, who cares? And here we are, actually something good comes out of it. So, it was incredibly tough. It was incredibly tough, but also rewarding. And I could see over 20 years, the asteroid community, the asteroid science community growing to such a pace that was also encouraging us to keep going. And now, now with a few space missions going to Asteroids for other purposes, taking samples and understanding more and more about these objects, it's fascinating to see how we fit into that puzzle. And something that was so strange 20 years ago, everybody agrees that it's the thing to do today, and it's actually obvious 20 years later that we should have done it.
Let's go back to your first baby steps. So you become part of, at the lowest part of the ladder,
absolutely,
of that team. Let's take it from here. How did you move on?
So I was learning. I was
what was your job?
I mean, I was what we called young graduate trainee. So I was a trainee. Then I became a contractor, and then eventually I became ESA staff. My role was to help. It was a bit of everything, actually. It was like if you're working for a small company, and one day you do advertisements, the next day you do financial accounting, and then you go and look for suppliers and all of that. So that's really what we were doing at the time. We were 2-3 of us. I was helping the system engineer in the spacecraft design. I was writing procurement documents to contract industry.
The fun thing.
Legal documents, articles for the press, doing interviews as well. A little bit of everything, really. And supporting my management into convincing decision makers to fund us, which we terribly failed at the time. So having meetings with what we call delegates, so representatives of the different member states, countries belonging to ESA. And also working with NASA. There were first sparks of planetary defense at NASA as well. So we're trying to coordinate and maybe find ways to work with together. So it was.
So they had their own planetary defense thing, and you had yours. And at some point, you said, "Hey, let's team up."
Correct. One of our, I think, the first step was with NASA Ames. We were working on a mission concept or a mission design that required what we call a kick stage. It's a small motor that you would add to the rocket to get you to the right speed. And the kick stage available, the cheapest one was an American one from the US. And we're trying to see if they could contribute with some of these elements. So we were inviting NASA colleagues to our review meetings, project review meetings, and see how they could fit in. So that were the early days of planetary defense. And then, of course, they grew up a lot faster. Actually, they established a fully fledged planetary defense office much earlier than we did. And but since then, we always worked together, one way or the other. We always coordinating, and now everything. I mean, the ESA planetary defense program is also very well established, and all the interfaces are there. So we made huge progress in 20 years in the field of planetary defense.
You mentioned that you had problems finding the funding initially. How did you win funders over for such a project?
Maybe one thing that everybody says is that I'm extremely stubborn. I'm extremely stubborn, and I really believe in my dream to make this mission happen. And I also there's a bit of ego where I wanted to prove that I was right. So
ESA made the right choice.
So in 2016, is the day where or the year where I had the biggest setback, because we went to what we call a Ministerial Conference, is where you have all the ministers of the 22 countries that are responsible for the space budget. And that's where ESA proposes future programs, future projects for them to fund. And it was the first time we made it to that level. Normally we were killed even before getting there. And that was in 2016 was the first time we made it to that table. and it was a huge achievement. And the day before the meeting actually lasts 2 days. The day before the first day, we had a reception, for what in other domains you would call the Sherpas, all these people trying to have these side discussions to prepare the grounds for the next day. And I was receiving huge positive comments on the mission, and from a lot of colleagues saying, "Yeah, finally, this is going to work." And I'm hearing that there's good support for the mission, and we're confident we're going to make it. Also from my management level, I didn't want to give it too much hope, but inside I was super happy. And then the next day, so I go to the meeting, and the mission is finally on the table. And the way it works is actually that ESA announces the projects, and every minister says how much money they want to put on the project.
It's like in a casino.
Exactly. And yeah, it's true. So at the time it was called the Asteroid Impact Mission, and the mission is announced, and then they call up every single country, and I see no funding coming.
No.
Yes, zero.
So you would sit in the back of the room and there's no funding coming in?
Yes. And I'm like, whoa, what's going on? And there are different rounds. Okay, so they do different rounds. Then there are splinter meetings, all that. So in the second round, there are a few million that start being put on the table, and I say, okay, maybe this is the start, the slow start of something bigger.
Of course.
We were asking, if I remember, 180 million euros at the time, and we arrived at 75 million euros, which is kind of short. I said, okay, but there's one more round, so hopefully, and then in that final round, instead of going up, actually a few countries announced that they would transfer all the funding that they put in the previous rounds on the Asteroid Impact mission to other projects. No. So we went from 75 to 20, something like that. And at that point, yes, I was pretty shocked. We had a splinter meeting with representatives of the different countries, trying to understand what was going on. But in the end, it was clear that there were bigger interests than this mission, and the funding went away. Just scrubbed it.
Wow.
So
that was 8 years of work for nothing?
That was 8 years of work for nothing, yes. And the hardest day for me, because I literally worked every single weekend, every single night until 2 a.m. It's difficult to express the amount of effort that we, because it's not just me, and the whole team, the scientists, everybody put into this effort, into this mission. It was huge work. And the worst thing is that the Ministerial Conference itself was extremely successful. So ESA got...
Of course, they got a lot of money from your mission.
But they even increased, as ESA, we increased the budget, 10% compared to the previous Ministerial Conference. So there was a huge party that night, ESA party, and everybody was celebrating. We had even connection from the space station, astronauts celebrating with us. And I was just crying. And probably I was super tired. I could not stop crying.
Wow. Were you at the party?
I was at the party. Yeah, that was my mistake, I guess. But I felt like, okay, I'm part of ESA, and there's something bigger than me. So I was with the rest of the ESA colleagues. But at some point, yes, I left the party, and it was just too hard. So that was a hard day. That was a very hard day. I will never forget. But yeah.
Where was that conference?
In Lucerne, in Switzerland. And I remember leaving the party and in tears, and probably cried for the whole night. And I thought, okay, that's it.
What's my plan B?
I gave so much of my personal life to this project. Is it really worth pursuing? And after all, if you get to this level, and they tell you no, why going back again? Why trying again? So I said, okay, that's it.
That's it.
Yeah, that was the Lucerne moment, which was the hardest, I think, in my professional career.
Wow.
And of course, also you can imagine all the colleagues and all the people that fought against the mission, because of course, when you try to get funding for a mission, many others believe that's money that you're taking away from other projects. So of course, this helped others. It was really tough. It was really tough.
So what was the first team meeting like after that announcement?
The first team meeting, I think I literally cried again. And it was a sad moment. Also, yeah, you have to imagine that by that moment, we had not only lobbied politicians, but we had lots of industries with us trying to push for the mission. So literally hundreds of people waiting for this project to materialize, because the space mission, once it's implemented, normally involves something like 500, 700 people working on it to manufacture the satellite, the spacecraft. So there were all of these people kind of waiting for the good news and to launch contracts.
And you had already teamed up with NASA also, so maybe NASA was also waiting for...
NASA was waiting also for the good news. Indeed, it was a setback for them as well. Fortunately, they managed, so the mission had evolved, the early Don Quixote mission evolved in a way where the two probes were kind of independent, could work and had their own life even independently. So that was actually one of the factors that allowed us to continue, is the fact that NASA, despite the setback of AIM, managed to convince Congress to fund the DART mission and continue. And the other game changer was the fact that a couple of ministers were extremely vocal on the interest of a mission like AIM, and asked at the end of the meeting in Lucerne that ESA continues its effort to do a mission like that. Of course, one or two ministers are not enough, but at least gave ESA the mandate to continue working on it. And of course, I took it quite personal. So after Lucerne, I thought, okay, I failed. I actually felt like I failed the whole group. I was not good enough to get the funding. So my first reaction was to pass the baton to somebody else in my team and say, look, probably I'm not expert enough. It was my first ministerial, so that also I thought, okay, played some role. I was not experienced enough, so maybe somebody else should take care now. And I was really convinced to do that. It's not easy, because by then I had all the interfaces with the politicians, with industry. It was Patrick Michel, I remember, calling me and say, look, you cannot give up. We have mobilized all the Asteroid community. We are all behind you. We're going to call ourselves the ministers and convince them that they made a big mistake. So he really went on a mission to get this mission done. And it's funny, we have this little joke among us that it's we always tell our families and friends that, okay, it's the one more try. It's the last time we try. It's the last time we try. And
I promise that I'll be home.
And then I promise I will stop. But there's one more try I need to do. And I think this one more try lasted another 4 years. And
to the next ministerial.
To the next ministerial. And again, we went into this loop of funding, some money, some funding to continue studies and continue improving the mission concept and the design. Luckily, Germany gave us another chance, and they gave us some funding to work with industry in rescoping and reoptimizing the asteroid impact mission. And that's how the HERA mission was born, from those early studies that lasted a year and a half. And from there we had some kind of a snowball effect that allowed us to go to the next ministerial and be successful. Of course, the fact that NASA managed to secure the DART mission was a key factor. But on the other hand, we had another issue, is that politicians and many in ESA also were saying, okay, you failed in 2016, NASA is launching DART nonetheless, so what's the point in getting to the asteroid after the impact? You're not going to see the before and after, but only the after. So we spent months and months and years to explain everybody that in space there's no weather, so the crater will still be there years after the impact. The reshaping will not change. There are many all the things we want to measure, the structure of the asteroid, the composition, etc., etc. There are things that we want to know and we need anyway. And so we had new arguments we had to fight against. But yeah, it was an incredible human adventure, I would say. All the scientists, engineers, industry pushing for this mission. And yeah, I can't believe we made it.
Fantastic. So tell me, how was that ministerial in 2020? So you were again in the same room waiting for the ministers to chip in their money. How was
Correct.
And you were traumatized already.
Yes. I can tell you I was literally shaking. My hands were shaking in the meeting. I was extremely nervous. I remember the feeling of the first calls for funding, which was completely opposite to what I lived in 2016. Every country started to put more money than I actually asked for. And I could not believe it. I was like, wow, this is even more than I asked. And at the end of the first day, we had what we would say an oversubscribed project. So I was calling everybody. But I wanted to, after what I lived in 2016, I was extremely cautious because I feared that at some point countries would realize and move the money away and put it somewhere else, and then go again below. But no, in this case, funding kept coming, and we ended up oversubscribed. So I was shaking, and I was in a listening room, and I left the room, and I went to a window and started crying again. This time for joy, joy and scare, because I felt the pressure now of delivering. There are many things that I haven't mentioned, but the fact that we were proposing a space mission to be implemented in 4 years is something that nobody ever done before. And Mr. Carnelli had never managed a mission before. So how can you have somebody who has never managed a mission to do it in less time than anybody would do to do planetary defense? Is something like hardly anybody believed we would make it. So I totally felt the pressure of delivering and proving that it could be done. But that's the second episode. That moment I felt the pressure, but also the joy, and I started calling Patrick and all the others, all the scientists, all my team at the time. By then I became the project manager myself, and it was a huge amount of joy. Unbelievable. And we're all hugging and cheering and partying for days until my boss came to the party and say, okay, now that you got the funding, we need all the legal documents, all the procurement documents on the table in 2 weeks. if you want to make the mission. And we were like starting to realize what we got ourselves into. And that's when all my hair turned white. In 3 years, it was a huge amount of work. But the excitement of having the funding, and to be frank, we also were more comfortable when we thought about the funding. We could take more shortcuts. Thanks to that, helped us to move forward. And industry shared our passion. And here we are building the space. Actually, we're right now final testing of the satellite before launch.
This is so fascinating. So after that great victory, so you had the money, you were overfunded, then you had your boss call the shots, so to say. Then the assembly of a team, the assembly of industry partners, the assembly of the constituents of that mission started to be happening. So walk us through the stepping stones to where we are right now. What were the challenges on that road?
Okay, so
maybe there weren't any.
Everything went different from what I expected, of course. There are a lot of personal things also in the story. First and foremost is that knowing my limitations, I never planned for me to be the project manager of the mission itself. To be credible, I believe I needed somebody with the right experience and the right mindset to lead such a project, and somebody who had done other satellites before, proving and have done them in a bit of a, let's say, innovative way, with the right dose of pragmatism and focus that are needed for a mission like this. And unfortunately, this person that I worked with for the preparation of the AIM Asteroid Impact Mission and HERA was no longer in a position to manage. So he was the person I counted on to lead the mission. And he was unfortunately not available. So my boss turned to me and said, look, you wanted the mission.
You got the mission.
You got the mission, and now you have to make it. And the main reason being that I was the one who knew most of the details and all the pieces of the puzzle that I had agreed with the various countries. So when you plan a mission like this, every country puts funding knowing which industry will be joining the project and providing which piece of equipment. And this was part of the, let's say, the deals before the ministerial, and now we had to implement them. And to implement it means you need to negotiate. So I was the one knowing all the pieces of the puzzle, and therefore of course I felt the responsibility of doing it. So I took the leadership. At the time, I still had 2 jobs because I was formerly doing something else, which is preparing future missions for the agency. So AIM and HERA were a bit of a side job for me, but then I left my real job and then worked full time on HERA. So that was the first big change for me in a job I never done before. So for me, it was total uncharted territory. The second thing was and together with that, forming the core team that would support the project, not support me, because I always told them that I'm part of the team. I'm not, I'm just one of them. So they're not working for me. We're working together for the mission and for ESA and for Europe. And my management style has always been very, very, let's say, transparent and team player. I'm not micromanaging. I needed to trust my team, and I told them straight away I knew nothing about mission implementation, so I counted on them to lead me through it. Of course, I would take my responsibility, and I would be the one finally, be responsible for it in case things went bananas. But all of them had all the freedom to work.
When I visited your office at Aztec in the Netherlands, it was very clear to me that you're a team player because your desk is just one of many desks among your team in one room. So you don't have a special place.
No, actually, I tried to take the worst place myself, far away from windows, because I wanted to show that it's not because I'm the project manager that I deserve different treatment, and I'm really part of the team, and we are all part. But I pretend the same from the others, so we all have to rely on each other competencies to make a mission like this happen. So there is no one better than the others.
So it's all for the mission.
It is all for the mission. It is all for the mission. Then, of course, I'm not naive enough to say that we don't take, let's say, personal benefit from a successful project. Because, of course, if you are successful, you become a model for others. Sure. But it really, for me, the motivation was to prove that ESA can do things in new ways, in different ways. And that new space, what is called new space, is not only about startups that have big dreams and little experience, but is about doing things we know to do in the best possible way, meaning we don't need to micromanage industry. We don't need to tell everybody exactly what to do. We need to trust each other and focus on the important things.
So you would go select an industry partner and trust, once the selection has been made, you trust in their ability. So you wouldn't interfere with whatever they are doing on a daily basis. Is that the approach?
It's not exactly like that. It's instead of micromanaging everything, which is or managing every single aspect of the mission, which is typically what we do, is to look at what they do best and what they do worse. And what they do best, we let them do it. And what they do worse, then we work with them. Okay. And it's not even micromanage. It's not even, I always say we are not managing, we are working together. Yes. So we're bringing ESA experience, ESA expertise to help industry and work together to achieve the objectives. Is not to tell them how they should do it, but we do it together. This, I think, has shocked the industry in the beginning, because normally industry sees us as a customer. So normally they don't even want to show you everything they do. They say, okay, we have gate reviews, we go to the reviews, and we show you how we have progressed, what we have done, etc. But you don't have to mingle too much in what we do. And I try to break this, because in the short amount of time we had, we could not afford the typical gate reviews and things. So I said, no, I want to be part of the team. I want to work together so that when we do the formal reviews, I already know I don't need to go through the 1,000 documents and try to find the errors and maybe correct. I want to get there in the best possible way. So we need to work together. And there were areas where industry is very experienced and they don't need our guidance. There are areas where industry was the first time they were doing things, and we brought experience, for example, from the Rosetta mission, other missions in ESA that could help us move forward. So the spirit has always been, let's put on the table, both in the ESA team, and then we spread a little bit this philosophy with the industrial consortium. Let's put on the table what we know, what we don't know, and use this collective knowledge to fill in the gaps the best possible way. So my first speech to my team was, look, guys, you all know I've never done this before. So don't count on me to tell you how to do it. But you can count on me to help you work in the best possible way. So I always strive to give my team the best conditions to work, the best environment to help them with industry when industry was not going in the direction they were expecting or they wanted. When difficult decisions were to be taken, I took responsibility for it, of course, but I always asked them, for their solution or for their view on things, and that worked. That worked well.
What were the most challenging setbacks, and how did you overcome them?
How much time do you have? So we have a dashboard in our meeting room called the shit list, and where we put only let's say the top ones, and I think we're at something like 38 is 40, if I'm not mistaken, like this week.
40 problems.
40 problems, but the big ones. One actually is not there. The very first one is that we released the invitation to tender to industry to bid for the mission. And of course, we had built all the financials on discussions with industry to figure out how much equipment would cost, and then all the engineering needed. And so you do a financial plan. And that's how we defined how much funding we needed, the ministerial. And we expected a proposal for a certain amount, and we received a proposal which was 50% higher.
Higher.
Then even the oversubscription was not even close enough to what we needed. And that's like, that was a hard moment, because it's like, you always know that there would be a little bit more and you would have to negotiate. Sure, I was not naive.
But that was too much.
But that was like, that's way, way more than I expected. To the point that I honestly thought, okay, this is it. There's no way.
Is there an option to go to a different player, a different industry, or is the industry so selected there's just one?
Normally you have a competition indeed. In this particular case, we have done the competition before, so it was implemented also because we had only 4 years to do the mission, that the selection had been done before. So we were in a specific case that we call direct negotiation. And we were in direct negotiation with the industry leader and what we call the core team, so a group of industries. Then we still had to select a lot more, but let's say the core team is what was part of the initial negotiations. And that lasted, I think, a month and a half. And I remember nights and nights and nights with Paolo Martino, my system engineer, trying to figure out how to scratch every single euro from this contract. And eventually we had to, eventually we had to escalate it to our director and the CEO of the company to make a deal. But it was really the first big surprise, because after all we went through, the two ministerial, I was counting on industry. Money. I had the money. I was counting on industry to be on our side and start as soon as possible, not to spend months and months in negotiations. So that was, I would say, the very first disappointment. And we were burning time. I mean, we had a contract ongoing, but we were burning time. So I was super stressed at that moment. That was the first setback. So then we finally signed the contract in September 2020. That was a very special moment. I have a fantastic picture I look at sometimes. Also to remind me how naive we were at the time, thinking that after contract signature, everything would go by the book, right? And we were still in the happy days. I mean, it was a happy project, but a lot of things happened after that. And so we signed the contract in September, and then in January it was COVID lockdown. So I had literally saw and met with my counterpart in industry, the project manager in industry, only once during negotiations, which is probably not the most pleasant meeting you can have with the counterpart you have to work for the next 4 years. And then we never met again for over a year. So all the sub negotiations, all the work had been done remotely. And that was also pretty tough. How do you build trust? How do you build a team spirit?
Without ever meeting.
Without ever meeting. And I was pushing everybody to use mask and everything, but still try to have meetings, and that was not possible. So that was super tough, especially because in my mind for years, I always thought, okay, once we have the funding and if we ever launch the mission, what I really want is to enjoy teamwork, right? And then all of this fell apart. There was no way to work together as a team. So I started to organize online seminars about asteroids with the scientists to engage a little bit the industrial team. And that proved to be well received from everybody and successful. So every month we had a lunch lecture from one of the scientists so that engineers could be exposed to what asteroids are. Why are we doing this mission? Why are we trying to do it in 4 years, and so on and so forth. And so that was one part of the story. And then from then we started to manufacture equipment, and I think everything that could have gone wrong went wrong. Starting from the fact that the electronic components were lacking because of COVID. So things that you had planned would take a few months to be shipped started to take 6 months, a year. And then we received components that were really bad quality. I remember the first time receiving an optocoupler that had human hair inside, glued inside. And
that's totally space ready.
Yeah, exactly. But the funniest was, I think the funniest component was there was somebody hand soldering a very expensive microprocessor on a board. It's one component alone costs, I think, 150,000 euros because it's radiation hardened and so on and so forth. So imagine the operator as the board with all the components, and this is the last bit you need to put in. And he's about to solder the component, and then when he has it in his hand and then looks at it to double check, there's a whole procedure to double check the code. Then he sees a print saying, dummy for exhibition only.
No.
So the company had made a mistake and shipped a component that was, those you put on a table in fairs and exhibitions for promotion or what. So that's one of the but we had so many. We had lots of setbacks. We had components breaking. We had operators that made mistakes, and one of the earliest was a piece of the satellite, a structural element we call the central tube. It's made custom made, of course, in carbon fiber. It's actually the element that holds all the weight and effort in the satellite during launch. I won't tell you the cost, but it's a very expensive piece of equipment, and it was also a long lead item. This is the backbone of the satellite, the first thing you need, and everything else needs this element to continue. And we were a bit late. Anyway, the component is built, and we need to test it. And the last test is a static load test. So you have the tube, you put a huge mass on top, and you have to check that it doesn't break. And to do that, you glue sensors on this tube. And the operator was not experienced, and also because of COVID was alone. So he was sending the tube to glue the sensors, and he sended it so much that it started to break the carbon fiber layers in 18 different places of the central tube.
Okay, how do I tell my boss?
until somebody found out and stopped the guy.
Wow.
But the damage was done, and I think it took over a year to design and manufacture this piece. And I remember it was a Friday when we were called for a meeting to discuss the problem. I was like, okay, this is, the mission is done.
No.
It cannot, and I was like, cannot believe it. After all these years of effort, now it's because somebody mistakenly, sanded a piece too much and broke everything. Lot of sleepless night. And during that meeting, we started to discuss all kind of different solutions. And I started to think, okay, what if we start remanufacturing? How long it would take, and all the snowball effect. So that was the first setback, and fortunately it could be repaired, but it was crazy. So we literally had to create molds to manufacture layers and glue them on these spots. And when I thought that, the solution seems pretty straightforward, then we realized that the inside of the tube is where you had to actually put the tanks, and the tanks only had 2 millimeter distance from the side of the tank and the tube. And the patch to fix the central tube had to be smaller than 2 millimeters, first of all. But even so, there were some parts that would not actually go through. So anyway, we had to find a procedure where you would lower the tank, then turn it a little bit, lower down, turn again. And I mean, it was a mess. But fortunately, it kind of worked out. I mean, it worked out. But it took weeks and weeks to find a solution, and the whole procedure and many things. And that was just the start. So we had equipment that broke during manufacturing. We had the operator using wrong parts. Instead, so using ground components rather than flight components. We had equipment that got lost during shipping. We had all sorts of stories, and then of course, last but not least, Ukraine war also kicked in. So we lost our launcher, which was a Soyuz at the time. And the Ariane 6 had delays. We had to go with Falcon 9. We had the companies burned down. We had our boards being manufactured when a fire started in the company and everything got destroyed. And we had literally to go to other suppliers that, of course, were overloaded. So I had to negotiate with all my colleagues who were managing other ESA missions to jump the queue and be in front. We had lots of stories. Wow. So, and last but not least, parts that broke very recently during testing, and we had to dismount the satellite.
Which is an easy thing.
Which is an easy thing. So you have to imagine that there's very little room inside the satellite. And I must say we have fantastic mechanics in industry who were able to literally sneak themselves inside the satellite without touching anything, and removing just the equipment that needed to be fixed.
Because the problem is, if you had to disassemble the satellite, you would have to go through the entire testing process from the beginning. Absolutely. Which is not possible.
That is not possible. But also there are parts you cannot disassemble once they're assembled. So it's very tricky, especially when the satellite is finished. It can be very, very tricky. For example, there's one equipment that now we know it's underperforming at low temperatures, and one would say, okay, we just swapped the unit, but in reality it's behind the tank. So to get there, you would have to dismount the tank, and it's impossible.
Wow.
So you have to find other solutions, like adding in this particular case, we're gonna add thermistors to keep it warm. But okay, this is I guess this is more normal to every project, but things like COVID or fires or accidents or people leaving, this is also something I'd not thought about before. I would imagine that once you're engaged in a super fast and super exciting mission, people, especially in the core team, will stay, until launch. Whereas people have different objectives. They move to another project, and all of a sudden you lose somebody who is expert in a certain domain, is key to the project. This happened, unfortunately, too many times. And finding ways to substitute and to cope. So the human resources are really the resource that make it happen.
Now, hearing all this is next to unbelievable that you're getting ready for launch.
Yes, we are still limping a bit, a bit more than we would like to, but I think in such a short time is what we could achieve. But yes, it's unbelievable, and to the point that many are asking us in disbelief how we could do it. Of course, we took a lot of shortcuts, but I think if there is one thing is people engagement. The ones working in the core team gave their
everything
soul to this project. Weekends. We are funny WhatsApp chats where wives are complaining about, wives and husbands complaining about working during holidays. I get pictures of people at 3,000 meters with a laptop working from a hut during a hike. And that shows just the commitment and the passion that we all put into this project.
In times of artificial intelligence, you are still relying on very analog methods to keep track of everything. Is that right? Someone told me if you lost your black notebook, that would be the end of the mission. Is that right? Do you have it on you?
I wouldn't be so dramatic, but yes, I do. I always have it with me.
So tell me, what
no
is
matter
the black
I
notebook
go,
about?
but this is a black notebook. I have a few actually now through the project. I have a collection, but even more so post-its everywhere. This is my short-term memory. I always believe that by writing things, they stick a lot more in my head than typing them. I know it's a little bit anachronistic, but even worse than this, my calendar is a paper calendar where I can see the full year in one view, and I can write and cancel my most important milestones and meetings on that. But this is where I go back to find out what decisions we made and why, and critical areas of the project.
Wonderful. Ian Carnelli, that was a tour de force through your world. All the best for the launch, late October it is, and for the mission.
Thank you so much, Marcus.
Thank you so much.
It was a pleasure.
It was fun.
Thank you.
Wonderful. Hey, it was cool.
Thanks. Thanks.